So colleagues, just to give you some context of where this conversation started that ended up with Michelle joining us today, Stephen and I were attending at the HOD's workshop earlier, a couple of months, I can't even remember ago. And I was in a conversation with Michelle, and she was telling me about how she teaches specifically to her master's students, Michelle, on how to use data visualizations to the best effect. So what works, what doesn't work, and what is the best for the user who's actually using that data or using those visualizations, reading them. So I asked Michelle if she wouldn't mind coming and telling us a little bit about that, with the intention that hopefully down the line we might be able to create a kind of a webinar as one of our capacity building resources through DAS. So Michelle, thank you for being here. And yeah, I mean, we use a lot of these visualizations, so it would be great to learn how to do it better. Thanks.
Okay, do you want me to start talking now? Or
yes, go ahead.
Look, I'm hoping that the share is going to work. If it doesn't, Stephen, do you mind if I email it to you and then you present and I'll talk over it? So it may crash on me because Teams has done this before. I have a Mac and I don't know. So that's my plan. So let me try, and I will try not to waste time if it does crash. Great.
No problem. You're the only thing on our agenda today, so we've got all the time.
You could spend hours with me with technical problems. Okay, let me try share now, hopefully. Okay, can you see?
Yes, wow. It's not in slideshow mode, but I can see it.
Okay, I'm going to put it into full screen. So I think, is that all right?
Yes. Perfect.
Okay. Great, thanks. So please interrupt. What I've done is extract some key slides. It's a bigger course, obviously, that I give, but I extracted some information from my visualization course that I thought may be sort of a whirlwind guide to designing visualizations from a sort of theoretical point of view, and to give you a feeling for how it can help. So I don't think I have to make the case that visualization is important. What I often say to students, because computer science students often don't see the value of visualization. They think it's all about, it's just the user interface, I've been told before, is that, if you buy a Ferrari, as a lot of them want to, you're not just buying the engine, you're buying the chassis and the look of the thing, and how well you interact with all the tools there. So that maybe sometimes gives them a feeling that it is important. And what I try to do in the course is generally give an idea of visual principles for visualizations, but justifying them in terms of a very high level overview of how our visual system works. Because humans' visual system it's a huge part of our brain. We're very visual, and we process visual stimuli in parallel, which is not like audio, which is very much sequential. So we can process quite a lot of visual input at the same time. So I just thought I'd Edward Tufte, or Tufte, is known as the grandfather of visualization, and he wrote, I don't think he's still around, quite a few very beautiful books on visualization. And he actually created his own press in order to print them the way he wanted them printed, because a lot of printers wouldn't do what he wanted. So, by visualization, we basically mean the graphical representation of data or concepts. So it's not art, though it has a lot in common with art. And that these graphical representations increasingly are tools to help you think visually. So when you're presenting evidence, you should think about the tasks that people are performing, which is often understanding causality, making comparisons across many variables, examining the evidence, and assessing the credibility of the evidence and conclusions. And so when you're designing a visualization, you need to think about what people are doing and try to make what they're doing as fast and efficient as possible. So I like this quote as well, and it's really a response to visualization that I resonate with. That science and art have in common intense seeing, the wide-eyed observing that generates empirical information. So a lot of art, when beautifully done, when it's representational art like this is really a very complex visualization. And this is really why I got into visualization. So my research is in computer science, specifically molecular modeling, hence the pictures of the molecules. But I also do a lot of oil painting on the side, sort of an obsessive hobby of mine. And that has informed a lot of how I think about how I present data. So, you know, art has a different end goal, but the processes of seeing and of appreciating are the same. So I usually show this to students to justify why me with, you know, I don't have a qualification in visualization. I'm not sure where you get one, but I've done a lot of visualizing myself, both in science and in my hobby. So please interrupt me if you can. Everyone still hear me?
I'm going to leave my camera on. I also hate talking into a voice.
No, it's just I once gave a 20-minute presentation to very polite master students, and only after that did they suddenly say, I can't actually hear you, Michelle. So, yes.
I just have to say, wow.
Oh.
Wow. That's all I'm going to say.
Oh, thanks. It's an obsession. So I'm very passionate about visualization, but I think most of the visualizations we use are, you know, calendars. This is an old one from 2020. I think we do know that a good visualization is a tool that helps us think much more efficiently. So a simple one is a calendar, and I think the calendar visualizations are increasingly good. But I tend to prefer to see the whole week, or even I think the month visualizations aren't that great. They don't work that well. Those could be improved because they're sort of frustrating. But our week visualizations are quite good. On a day-to-day basis, you don't have an overview of what's coming up. So the problem is that ineffective visualizations are far more common than effective ones. And I have done it. I've stopped doing it as I've gotten older and wiser. But, you know, people don't take it very well if you point out that the visualizations they're using are ineffective, but they often are. So I'll have colleagues or international conferences, people present really bad visualizations of their data. And you really need them if you're doing a presentation to be easy to assimilate. So this one, for example, which is some flight path visualization that I found, it's incredibly difficult to follow any path or to get a feeling other than there's lots going to the UK. One assumes that's Heathrow. You know, Spain has fewer, Portugal, which would be Lisbon, would have even less, things like that. But as soon as the paths overlap, this visualization makes it very difficult to see or even extract much more information than lots versus little. And it's very hard even to say how much, because this line over here seems a lot thicker than here. So this is not a great visualization. However, if you told someone this, they would get quite defensive. And even if they asked you for advice, you would have to have some justification on a theoretical basis that, for example, people find it very hard to follow overlapping lines of the same color. You would have to say to them, and that they find it very hard to estimate area, which is what you're asking people to do in these round circles, as opposed to a length scale. Lengths are much easier for us to judge, for example, which is what I teach in my course and why. Another visualization, I'm not even sure of what it is, which is a failing of a visualization, because even if it's interactive, on the first page, you should have a feeling of what they call gist. What is this about? That's the first question people ask of a visualization if they're looking at it. I have no idea, except there's some kind of ranking here, and it seems to be government DNA. I think it's a metaphor. So this is a winner of the Information is Beautiful prize, which is an indictment of how people judge visualizations, because it's even incredibly hard to read this text here, and it doesn't need to be. Things that are small can be very visible. So, you know, another example of one, the runner-up prize, that is a very bad visualization because it's very, very hard to distinguish these lines from each other. This one, it's easier to see that it's GDP, but you have to read it per capita. This color scale is odd. And we're not sure which country is which. A bad visualization, even though it was a runner-up prize. People love to do 3D in visualizations. It doesn't work. One can demonstrate that we are very, very bad at judging 3D volumes. The only time you should do 3D is if your data is intrinsically 3D, that people have to appreciate it. But this would be much better presented as a series of bar charts, rather. I'm just whizzing over these. My people love circles. I think this is interactive. I'm not going to play it now. Very, very difficult visualization to read. You've got countries here. You know, at minimum, you could actually show the flags so people could look for countries they're familiar with on the side. Here we're trying to show which countries won which medals at the Olympics. But to actually judge how many Germany won, you can't go to gold, silver, bronze and know which ones belong to Germany. You'd actually have to trace them back. The colors even change as you're going, which makes it harder. Very difficult to see. Hang on, next slide. Here. Another visualization taken from a journal that I look at quite often called Vaccine. And this was so bad I had to include it. Multiple pie charts that vary in size. I'll get to, hopefully I'll have time to explain why pie charts are an absolute no-no. You should never use a pie chart. But this one is not just multiple pie charts. You're having to compare the area of each pie chart with each other. The different colors are also hard to distinguish. So, you know, there's lots of bad visualizations. The topic of my course in general is what makes a good visualization. One can show examples. This is quite a fun one. I don't know if any of you have seen the Big Mac Index of The Economist magazine. The Economist has put quite a lot of effort into visualizations, and a lot of theirs are very effective. So here, this is showing how undervalued or overvalued at the moment the South African Rand. It is interactive. You can go there, but all interactive visualizations should work statically as well, which is another big pitfall. You shouldn't make people have to click for their first view of the data. So here it's quite nice. You can look at the different countries, and here it's just illustrating how effective a little sort of bar charts, very tiny, can be. We're quite sensitive to bar charts, so you can put a lot of data on a page. You get immediate questions like, why is Oman blank and then a little red thing, as is India and Moldova. Don't ask me to pick out Moldova on a map. But it would most likely be that they weren't tracking these countries with the index until later. So it's quite a nice, very complex visualization here. Not perfect, but definitely on the better side of good. One example is people tend to pick red and green as colors. But red and green is about the worst pick you can do, because 8% of the male population is colorblind. And so using red and green together with no difference in saturation will mean that a large percentage of the population won't actually be able to see the difference. So red and blue is a better pick. And they've quite nicely here linked the South African Rand being blue with it blue over here. That's quite effective. Another sort of whole concept that I go into in my course about color and category being your strongest relation, and that so you should always keep that. So if you've colored something blue, that thing must always be blue later, because people expect that. This is the classic best visualization. It was done in 1861 and described by Edward Tufte as probably the best statistical graphic ever drawn. It's showing Napoleon's march to Moscow, where the width of the line is the number of soldiers in the army. The light tan line is the march advance to Moscow, and the black line is the retreat. And I get goosebumps every time I look at it, because you can compare the width of this little line here with that and know how many people died. You can also see where they died, because this is on a map, and there's also a temperature chart below. So, and, you know, crossing the rivers clearly awfully killed off a lot of soldiers. This is a branch that went off and then rejoined for the retreat. Very compelling graphic, all done by hand, and it's in French, but sort of it has a stamp of a great visualization where you can explore it, answer questions, and learn from the graphic. Other great examples of good visualizations, if you're looking for them, are maps and charts, because these show tons of information on a single surface in ways that the information doesn't conflict with each other. So here, I think it's sea depth here, doesn't interfere with the colors over it, the land versus the sea versus various features here. So cartographers have actually perfected their visualizations over hundreds of years. And so maps are often some of your best data visualizations that we can get for a particular kind of data. So what I'm really wanting to say is that most designs are ineffective of visualizations, because people decide them just to represent the data, to satisfy the problem. And they don't think about optimizing, which is more work, which is why people don't. But just some basic visual principles where you design a graphic and think, am I meeting the requirements of these basic heuristics that I have, would help. So if you really want to design a highly effective graphic, you actually need to deliberately generate lots of designs and explore possible solutions. But even just following some basic visual principles will help a lot. So I'm just going to go over a couple. The main one, stop me if I'm going too fast, is called pop-out. And it's acknowledgement that our visual attention works like a spotlight. We scan the environment and we notice things that pop out at us. And the question is, why do they pop out? And they pop out because they differ from the background on certain key features or channel. An obvious one is color, but it can also be, you know, width, size, blur, orientation, differences in space. And so the idea is that the most important questions that someone is asking of your graphic should be supported by the most visually distinct objects. So I'll give you some examples here. Firstly, what are the main things that lead to pop-out that you can go through? Well, you can have things being different according to color or orientation or size. Size is very effective. Motion works too well. So if you make things move, people will notice it. But if you do it even slightly frequently, they will get very irritated. People do not like to see motion. Motion should be reserved for like the alarm bell, the fire alarm, but because it is so incredibly effective, mostly because we are sensitive to threat, whether it's predators or other humans. And so any peripheral motion in our vision makes us orient towards it, and will distract you completely from your task. I don't know if any of you remember the Microsoft paperclip that used to jump up. Was hated, even though it was cute. The only person who didn't hate it I know of is my husband, who thought it was adorable. But most people found it unbelievably irritating, and so they killed the paperclip for that reason. So don't use motion unless it's urgent. And depth, which people very seldom use. So even a dropped shadow, which we have in this text here, will make something pop out. And it's really only these things that lead to pop out. And these are because they map to very basic areas of our visual cortex. We have areas of the brain that detect color, orientation, size, motion, and depth. So one should use these in a graphic. Yes, I'm probably talking too much here, but basically if you want to make something easy to find, you want to make it different from its surroundings, which are, I'm doing the metaphor over here, according to some primary visual channel. Channel is the word we use for this, but it's a feature. So color or orientation or size over the top here, or in space. If it's separated in space from others, it will pop out. And so if you want to support two different kinds of questions about your data, then you should use two different channels, so a color and an orientation. So I'll give you some examples here. This is taken from a book, Information Visualization Perception for Design by Colin Ware. There are very few people who are considered experts in visualization publishing. Edward Tufte is the originator. Colin Ware is the other one. And then there's Tamara Munzner as well. So if you're wanting to some literature, I can give you references. But here we can compare three graphs here. And we've got male, female, weight and height. Here we're just using shape, which is fairly effective, except their sizes are the same as well. So it's a little difficult to distinguish the females from the males. Here, these being birds. Okay. If you make them differ more in the type of symbol you're using, so this cross is thinner, bigger than the circle, it becomes immediately easier to pick out the males from the females and to see the pattern of distribution. And seeing a pattern is often what we're looking for, allowing people to explore, oh, there are a few down here, all the sort of low height, low weight of females, all the big height, big weight on males. Is that surprising? Probably not, that kind of thing. But it's even better if you then use another feature, color. So we have red circles and large, thinner crosses in gray for the males. This may seem obvious, but there are so many graphics that will just do this. Or just pick red circles and green circles, which is often what one would see, actually, because people love circles. And then, 8% of the population of men are not going to be able to see it properly, and a few women. So, do just a simple test of this here. Will show you that this is a much better graphic. Here we've got three items, shearwaters, gulls, and terns, the same situation here. So it becomes even more important the more data you're showing. So shearwaters, gulls, and terns, much harder to separate them and to just see at a glance. The test is, can you see what you want to see immediately? If the answer is yes, then it's working. Not after searching for a while, then that's work. And the more you have to do it, the harder it is. Here, the color makes it easier, but it's very clear that this is the best. Here we're using actually blur, which people use very seldom, and it's highly effective. We're very, very sensitive to blurred things versus sharp things. And it's not a problem finding the actual point because you've got this centered dark spot in the middle of the blur. So we've got the terns are easy to see that they're quite tightly clustered, the shearwaters, and then the gulls are more spread out. So a very nice example of how you can make things much more visible if you separate them according to color, orientation. This is also an orientation across size, blur, and so on. Blur is actually a depth effect for us. So any questions on this? I've got probably too much, so I'm going to skip over a few things. I'd rather make a few good points than exhaust you all.
No, it's all great. Don't skip anything.
Yeah, no, it's fascinating.
Like I'd never come across blur before as a
It's highly underutilized. So I do have a few key things. People tend to throw color. They just want color and that's all they use. But blur, and actually I've taken out a lot of stuff on texture. If you want a sort of longer thing, this is my passion. I'm happy to do it, but at a later point. But texture, which is also for bigger areas of data, highly underutilized for bar charts and so on. Yeah. Okay. So yeah, I was just showing, this is quite an effective bar chart, this one, that I found. I think it's from Nature. Nature actually has a lot of examples where I don't like what they do. The one issue I would have with this is this light gray bar is actually quite hard to distinguish from the background. It would be a lot better if you just put some slanted lines in it to distinguish it. But this is an example of where you're separating not just on color, which is what people tend to do, but on saturation of the color, which is quite important. Whoops. Not perfect, but better, and also in space. So one can jump around and make comparisons between the orange, and what they've done is they've made sure that all the orange bars are potassium, all the blue bars are phosphorus, and all the light gray, this is an issue, the fact that light gray is very hard to see against the white, are light gray, but I would put a black border around those. And perhaps the texture, and so my computer's jumping around. What is also interesting is that this number pops out because it's white on the orange where all the others are black, so it's different. It's also the longest bar, so we've got double pop out size, and that's interesting because you probably do want to draw attention to the global fertilizer demand here, the biggest being potassium. So this is not a bad visualization. It's just very little data, but one could improve it. Another tip, so if you just want sort of general tips, is that people tend to use rainbow color sequences very often because they're pretty. And a lot of people's design decisions come because they find things attractive. But attractive, which I think is the reason why people choose pie charts, attractive doesn't necessarily mean effective. So a rainbow color chart, we find it actually quite hard to understand the range that it's moving from from a little to a lot with a rainbow color chart. They just feel like different colors to us. Attractive, but different. Whereas a color chart here going from, black through gray to red is actually, red through white to black is a far more effective color chart for detecting, in this case, blockages in an artery. A sort of more easy to, this is from a journal article, but this one is another example that I found. This is from Our World in Data that has some nice graphics, but quite a lot of them could be improved. So it's a great source of graphics for exams for me. Here, they've used this rainbow color chart, and it's I'm wanting you to see how unintuitive it is. It's hard to see in 1800 life expectancy because it's all in the red. And red is good here because we assume that red means bad. So people are dying young with the red. But we don't instinctively think that yellow or this limey, I'm quite difficult with yellow. I often think things are yellow when people think they're green. So say lime green is lower life expectancy than dark green. So, one keeps on having to check on the chart about, is this higher than this, and so on. I mean, they've actually put the years in, which helps for us to check there, but the color chart or color scale is not very effective. It would be much more effective to use, this kind of color mapping, where you go from low saturation to high saturation. Okay, so low being little and high being big. You probably in this case wouldn't choose red because we would assume that red would mean danger, and you don't think that high life expectancy would be danger. But light green to dark green, maybe, or just gray and use the colors for something else would probably work quite well. so one could think about it, but there's lots of effective color scales, but the rainbow color scale, people love it. It doesn't work very well. We keep on having to look again, check things up. And as soon as you don't see it immediately, it's not effective. Another thing that I've noticed that people tend to find quite interesting is that we think that colors have a symbolic meaning. So I was saying we tend to think red means danger. This is not actually true universally. So in red, for Western culture, tends to mean danger. Green, I would usually ask people to chip in and tell me, but I don't think it works so well, I must do. Green, it's recycling, growth, environmentally conscious. Blue, cold, maybe. White is purity, marriage, that kind of thing. However, red, if you, in the East, China, it's good fortune and renewal. It's almost the opposite meaning. And, green can mean death. White can mean death as well, or mourning. So you need to be quite careful, and it's to be aware that colors don't necessarily have the implications that you think they do. And maybe try and go more color neutral if it's for a wider audience. Use colors that, the grayscale or blues tend to have less meanings than reds and greens. Okay. So I'm going to just go over, and then I'll sort of stop, some general practical rules of thumb. Now in my course, I'll justify these a lot and there's a whole lot of other content, but these I think are helpful if you are designing visualizations on a daily basis. So the first one is don't use 3D unless you're showing something like, this is a molecule I was building, a structure. And even then, showing it like that, you probably actually want it to move or people to interact with it if it is 3D. But otherwise, you should avoid 3D because we actually see the world more. We think we see the world in 3D, but we actually interact far more with the flat picture plane, which is why your laptop and computer screens work so well for us, than we do in the third dimension. So what they call pictorial depth, shadows, drop shadows, height on the picture plane, there's a whole lecture I can give on that, is quite effective. But actual 3D, sort of like 3D movies, everyone thinks that they love them, but we don't really. We're very happy with a cartoon. And some people say we see the world more as 2.05D because depth isn't as important to us as we think it is. And interestingly, some people are much more skilled in judging depth than others. So it's not a very universal thing for humans. And why I'm emphasizing this is people do it all the time to make really cool graphics. So this is New York City's population by day, okay, and then by night. And so it looks impressive, which is nice. However, if you're actually wanting to check particular areas of New York City without being to be able to rotate the map, you can't see items behind here because they're occluded by the ones in front. And something like this, a two-dimensional map or bar charts of the different areas would be far more effective for representing the actual data. One could have this at the top of a graphic for impact because it does have that, but it's not as a sort of tool for investigating and exploring the data. It's incredibly inefficient. So even if you could rotate this, you would actually have to manually rotate it on your screen to investigate it. And we don't want that. You must be able to just glance around and get the information you want. So people tend to think 3D is amazing, but when you try and make it work, it's exhausting to investigate. Okay, they also no unjustified 2D. So 1D lists or bar charts also have several strengths. 2D is good for relationships and structure in your data. So the example of this is pie charts. So to quote Edward Tufte, a table is nearly always better than a dumb pie chart. The only worse design than a pie chart is several of them, for then the viewer is asked to compare quantities located in spatial disarray, both within and between charts. Given their low density and failure to order numbers along a visual dimension, pie charts should never be used. However, everyone does use them, unless they're my students and they do it once. But the problem with pie charts is that you are requiring people to make angle and area judgments. And we find area harder to judge than angle. But if you show them a bar chart, all they have to do is judge length. And it has been shown that humans are very accurate in judging relative lengths, much less accurate in judging area. In fact, we tend to consistently underestimate area. So if you wanted to show a bar chart, show a stacked bar chart instead, which is basically a bar chart that they're all at the same height and you compare the stacks. Pie charts also require more screen area, so you shouldn't do them. And I'm sure people are feeling guilty. This is how I get people really upset, saying never use a pie chart. But it is actually a visualization principle that you should never do it. It can get worse. Yes, well, I've shown you this one already. 3D pie charts, also very popular because they look impressive. But for 3D pie charts, you're actually distorting the angles and areas. So if you look at the screen area of a 2D chart, and then the same chart shown in 3D, you're actually giving much more area to the pie that's facing you, the pie piece. So those are even worse. The only pie chart I've seen that I liked was this one that I got out of a magazine where they were comparing donut shops in Los Angeles versus in America. The point being that there's a lot of independent stores. And I thought in this case, it was quite cute how they did the pie charts. There's another principle. So there's no unnecessary 3D, no unnecessary 2D, then eyes beat memory, which basically means don't make people click. Put it all on one page and let your eye jump around. So here, it's quite nice to have a small, this one's quite big in this, but a mini map showing the area that you're showing in a bigger map. And switching between the two views is very easy for us to do. Very low cognitive load. A better example of this is something like this. Here, quite a nice graphic, also from The Economist, where they're comparing languages. Japanese, and note that in space, the Japanese is on the first row consistently, Spanish, Finnish, and so on. And this is how quickly it's spoken, and this is how much information is conveyed per second. And it's quite an interesting graphic, not perfect. One of my students suggested that what they could have done in the side here was actually print, say hello, in the different languages in their correct scripts on the side, which would actually help you sort of map which language it is, because we sort of recognize, say, Japanese kanji, even though we may not be able to read them, and so on. So I thought that would have been quite an appealing addition to this. But this illustrates the eyes beat memory principle in that there's a lot of data on the page, and you can quickly compare them up and down, left and right, jumping around. So if you wanted to compare English is fairly slow, but quite a lot of information per second. So is it true? So you can ask yourself questions. Is it true that the slow languages have more information? Because maybe there's more information in each word. No, not necessarily. So, for example, Thai apparently is spoken more slowly, but there's also much less information. So it's slow, and so on. So this is this concept that you should put as much as possible on the page, and in a way that allows people to compare things very quickly. So this is another heuristic. Grouping. There's quite a lot of rules about grouping if you're wanting to group information. The easiest way to group is to contain what you're grouping in an area. Then you can connect things. That's the next most powerful cue. Then how close things are to each other. Then how similar they are. So here they're all in the same font. And then you can also show grouping according to where you are in space, color, hue, motion, and shape. Okay, so if you wanted to show that something is part of the same group, these are your options. Then there is a Schneiderman's mantra, which is mostly to do with interactive visualizations, but it's a very useful thing to chant, which is overview, zoom and filter, details on demand. And Ben Schneiderman is one of the fathers of visualization as well. And an example I have of this is this nice overview of The Economist magazine and some graphics that they had. And it's quite appealing. You have an overview of the whole year, all the graphics that they had, illustrating how much information we can get from quite a tiny image. Okay, so that's that overview. Then you could zoom in on a particular one, or maybe say pick all the ones in a particular month. That would be your zoom and filter. And then details on demand was, if I want to know exactly what this graphic is, I should be able to click on it and see what it's about. But where I find a lot of graphics, particularly interactive graphics, lack is that feeling of overview. They often don't have it. So you often don't know where you are in the data, how much data there is, where am I in the timeline on this? And it's hugely helpful. It gives people a feeling of power and security to have an overview for visualization. So for example, if you have a data going for 20 years, but you're focusing in on the last 5 years, still show a tiny little window at the top with the 20 years and a little slider bar of where you are, because then people will be able to check, oh yeah, that's where I am, and so on, instantly. Okay, there are only a few more principles. Get it right in black and white. That's a very, very good one and very easy to test. So your visualization should be legible even if transformed from full color to black and white. This is not just for reasons of printing. It's because our visual system is the most sensitive in what they call the luminance channel, which is black and white. We actually only see detail effectively if there are differences in the grayscale. We can only see structure if there are grayscale differences. So your graphic should always work if you print it in grayscale. For example, this is a 2016 election map graphic that I found. And it was Trump versus Clinton versus other. And it's not wildly effective in the first place because they've used the same symbols and just colored them blue and red. So even just filling in the Trump one having a solid red dot and the Clinton an open blue one would have helped. And other is practically impossible to see the gray because it's very hard to distinguish gray from blue. Okay, if you print this in black and white, you can see it doesn't work. So the most crucial aspects of the visual representation must be legible if it's in full color to grayscale, black and white. And it is not here because the crucial thing is Trump versus Clinton, seeing as it's an election map. Here's one that is quite colorful, but does work in black and white. This is showing you, depressingly, numbers of species that have died of mammals versus birds versus amphibians and so on. It has some issues. It's quite a impactful visualization, but it does work in black and white because they made the red a lighter red than the saturation of the black. And so it will actually be easier to see. If you'd printed it and the red versus black cats, for example, would have been difficult to see. That would have meant the colors were the same saturation. And even though we could observe it, it is actually harder for us to see. So that's a good principle. Always print out all your visualizations in grayscale and see if they still work. Here's an example of one that doesn't. Very simple stacked bar chart showing percentage of women and men which have different autoimmune diseases. Oh, sorry, different diseases. Autoimmunes are more common in women, and diabetes are more common. Well, actually, women are getting the short end of the stick here mostly. So it's mostly about autoimmune. And when you print in black and white, it's very hard to see the division between these bars. It would have been easily fixed by using a light blue. And that will work quite well because we see blue as a darkish color anyway. So light blue tends to work. Or if you'd put a texture on the blue bars, and then it would have worked in black and white. So just a very simple example of where it's breaking the principle. And then the last thing I want to talk about, because I've got like a few more minutes, is another trap people fall into, is that they come up with this great idea and they think, oh, it'll look so fantastic, you know, like that 3D chart of New York City. And visualization, if it's really good, should be beautiful and effective. But the minimum is effective, not beautiful. So if beautiful conflicts with effective, it needs to be effective, and you need to get rid of the thing that's stopping it being effective, even if it becomes less pretty. So there's this concept of a graphical duck from Tufte, where, you know, it's all right to decorate construction, but never to construct decoration. And he named this concept of people designing a graphic that just works because it's pretty as a duck, after this shop shaped like a duck. Because someone thought, wow, isn't it great if we had a shop that was shaped like a duck or store? Except it doesn't really work as a store because there are no windows and it's all round and not very big. So its function as a store is impeded, is made worse by the fact that it's shaped like a duck. So it's a duck. So here's an example of a duck. Someone, I think this is also from Nature, decided to publish immigration data so that it looked like a tree. Why, I don't know, because it's cool, but it doesn't, it's very hard to see anything from this data except that it looks like a tree. So the years coming out, okay, so there's maybe less immigration and more. I'm not sure why it sort of bends in here or not. When you look closely, there's mixtures of magenta and yellow, which become a different color visually as you stand further back. So someone had this idea, it was really cool, and it's actually practically impossible to extract information out of this visualization. I have lots of other ducks, but I haven't shown them. So I just wanted to finish with this quote from Tufte, that there are right ways and wrong ways to show the data. There are displays that reveal the truth and displays that do not. And so your data graphics should draw your viewers' attention to the sense and substance of the data, not to, you know, how impressive it looks, the graphic design. And so I do think, particularly with the online tools, people can get carried away and think, wow, this looks fantastic, it's so unusual, but you're not trying to entertain people with data, you're trying to communicate as easily and effectively as possible. So your visualization should represent your data in a way that makes this easy, makes it easy for the viewer to understand what you mean. Yeah, and I know that it can be very seductive to use all the bells and whistles, bubble charts and so on, but you need to really think about, do they work? Okay, I think that is it. Click.
Great. Thank you.
Yes. Oh, hello.
I'm getting feedback. Oh, now I can see myself on your screen and on my camera. Stop sharing.
Let me stop sharing. How do I stop sharing? Oh, cancel share. Yes. Yes. Okay. Cancel.
There we go. Thank you so much, Michelle. It was really educational, like fascinating, and just all the things that one just doesn't even think about that we do wrong. But you know, but it just made so much sense to me. It made me think of when PowerPoint first started to put out like animations and things like that. And people started using shadow text and animations and things flowing out the screen. It used to drive me insane. So I mean, I certainly have learned a lot today. Colleagues, is anyone? Oh, Prezi.
Prezi.
Yes. I'm guilty of an occasional Prezi presentation, but I got over that pretty fast.
They are very cool, but you know, that's I think once you try it out, but then, you know, it's different if you're playing around, but if it's to communicate, it needs to be straightforward, I think.
Yes.
Yeah.
And make sure no one in the room gets motion sickness. Hey, colleagues, any questions for Michelle? I mean, I will have a million questions that I'd love to ask at some point, but I recognize we don't have that much time. Kende.
Hi, yes. Michelle, hi, I'm one of the DAS people here. Let me turn on my camera so you can see me. I just wanted to know, because you just gave us a very good insight into what and how visualizations work. And because we did send you about 6 or 7 reports earlier this year, about what we thought was like a good visualization for you know, a course convener to know about their students and their courses. If you remember any one of them, what do you think of them? Based on
I did actually find them quite interesting. I think Stephen presented one at the that workshop I was at. I'm not actually a head of department. I don't know why I was sent to that workshop. It's made me very nervous. But yes, so yes. So the pies. I would lose the pies. Yes. So seeing as you're asking me, I mean, I can give you, I think there was quite a lot of interesting data, but it's much easier to simulate the data from the bar charts than it is the pies. I like the fact that that green bar chart has different saturations of green. You could use, I mean, I could give you like a whole lot of little tips that would just, if you like, make it easier. I mean, even just making the background where you've got data, make the background white, you know, keep all the gray and that sort of thing. It's just the higher the contrast between the data elements, the better. And people tend to use a color in the background, but a white background gives you the best contrast. So I always have a white background behind data. I didn't give you any talk about color other than a little thing, but there's a whole lot of other things. If you've got a yellow edge, then there's quite a lot of things I could do to help you here. I found the data very interesting. I think you could present it, firstly losing the pies, but even your text here, gender, nationality, school, those could be much bigger because you've got lots of space. Make it bigger. And I would use symbols. I didn't talk about symbols very much, but symbols are very effective. People like them a lot. You know, like a school, that little mortarboard thing is a classic symbol for education. You know, I mean, you could think about the right symbols to use for that. That English and math, for example, that pops out very nicely, the 72, 87. But you may also then just want to have a bar across the bottom showing the length scale, 72 versus 82. Lots of little tweaks. Those stacked bar charts, I knew there was something I really liked in here because the pies, obviously for me, is like a no-no. That stacked bar chart, excellent. I would make the text on those bigger because there's no reason why you can't. And if it's on blue, it's okay because it's a light blue. Those work very well. I think I like the fact that the purple, which is the smallest in those stacked bar charts, is the most saturated, which is what I would do. So the bigger the one, the smaller the one, the more saturated you make it. Are you still keeping the same colors with the top pies?
Yes.
Yes, that's good. So that NBT pops out very good. Sometimes I use different fonts for different things, you know, so sort of like a certain font. I mean, I can go on for hours here. So, and, you know, let me, but that I think is working very well, that stacked bar chart. But I would have a bit more space on that principle of grouping between, sorry, go back to the stacked bar charts. A little bit more space between the NBT L performance. That gap needs to be a little bit bigger because they're all merging into one, versus the NBT QL performance versus the math performance. Or you could have like a gray background, which you've got there, and then just make it white background where the bars are. And that would help to separate it. I don't know if you're making sense, but you kind of...
Yeah, a white shaded block almost.
Yes, behind each little group. That would probably, and it would look, that tends to look very stylish because it's separating with a subtle difference in shade, and it's not the most important thing. So, you know, I mean, I can give you guys a whole lot of suggestions here. I would use your fonts bigger where you have them. Those bars at the bottom are very nice. Those little, like that, lots of data, and those years are quite nice and big. You can make it even better. That's really nice. That's that whole eyes beat memory thing. Yeah, you may want to stack them on top of each other rather. I don't know if that would work better so that you could directly compare them to each other, you know, so that you make them vertical rather than, but I think it's also working. No, because it's time. We expect time to go along the x-axis. So that, I think that looks very nice. Like the stacked again, just be careful of light white text on gray and light blue. That should rather be black. And it would also help to distinguish that bar. So if it's possible, you know, where it's light blue and light gray, make the text black, because otherwise the contrast is too low. Yeah. So, I mean, there's lots, I think, wherever you're using length scales rather than the pies, it's looking very nice. And what's at the bottom there? That looks interesting. Look, circles aren't always good, but they can work because, you know, we're doing an area comparison and people tend to find them quite appealing as well. So I'd have to have a closer look at that again. I know that I got some interesting data out of that.
Yes, this is one of yours was this.
Okay, so I'm not actually, yes. So you see, you could make my name as the convener in a different font. I tend to do that. I make people in a certain like Times New Roman font or something, you know, like just so that it's quite easy to find the name. So if you were comparing a whole lot of these, that you would immediately see the name, and you can make it bigger, the name, so that you know whose it is or which course it is, you know. I think that there's a lot working here. If you want, I could, you know, sit down and go through some more suggestions because, you know, I do a lot of this. This is basically what my course does. People design something and we go through how to improve it. But I think a main thing as well is that where there's data, make it white. And then it feels like data as well. So,
yeah. So we can call you.
Yeah, yes, yeah. As I said, this is my passion. I'm very happy to do it. It's sorry, when you first got hold of me, it was like end of year having term craziness. It's getting a bit better now. So yeah. Yeah, I'd just be a bit careful about those colors at the bottom there because they're all the same. You know, they're all the sort of red scale. And it's quite hard to read that white text on the magenta or pink background. So yeah, so because I paint, I'm quite specific about my color name. So that's what I would choose, magenta tube of paint if I wanted the pink. But there's like that orange and red, you know, you could pick green or good thing you didn't put pink for the gender gap. You see, that's the kind of thing that would upset some people.
So we actually Googled a lot. I spent like some time thinking about the gender gap colors, and so we picked those two from quite an interesting discussion about gender colors.
Yeah. Yes. Yeah, no, I think that does work well. You could also use textures. So I don't think you're using texture at all in your and texture is quite effective way of you know, it's another channel. So, and it doesn't have to just be lines, you know, you could use faint dotted, you could use leopard print, you know, there's lots of different textures you could use for the data, not just color. And it makes it sort of less visually tiring because it's sort of, I mean, sometimes you start using more emotive, unscientific language because this is an arty area actually when you get there, but it can be tiring to look at too many colors, you know, whereas texture can feel like a bit of a relief. So if you're worried about you running out of colors, because there's lots of different colors here, too many, I would say, texture some of them, you know, like little lines or dots or, but make them, you know, different kinds. Some you could slightly blur the texture. I mean, if you can do that with your tool, but you should be able to put a texture on some of them, hopefully, I think. Yeah.
Thanks so much.
Fantastic. We need to wrap up because we're running out of
It's
time.
not short.
But
It's not
this was like
Yeah.
been one of the best things we've had all year. And it's sort of humbling as well, because this is in fact like the, I don't know, third or fourth iteration, and we've substituted quite a few different representations and gone backwards and forwards. And so we kind of thought we were kind of doing well, but we see now we've actually only scratched the surface. And so we'd very much like to take you up on a more detailed critique.
I'd be very happy to do it. But I'd say I did, there's a lot of theory behind this. So it's not just sort of Michelle's opinion. It's really like, that's why I give the courses, that I say, students, if you're designing an interface, you need to be able to say to the client who wants it, this won't work because visually we don't see this that easily, that kind of thing. Not because, I hate the color. I mean, I do have certain hatreds for certain colors, but.
And that's really helpful, because otherwise it just feels like, the fussiest person, and then you get into arguments about whose opinion is best and that sort of thing. So it's really helpful to be able to ground it like that. And this definitely is a good Pumalele resource for the wider network. Rashna. So
absolutely. Yeah, I think people would find this as kind of an addition to their Know Your Data workshops. This could be a really great addition to that.
Yeah.
Thank you, Michelle. Well, that was like a completely serendipitous encounter that led to great things. So that's super exciting. Thank you so much for your time and generosity. And we're not going to let go of you now that we know. Thank you.
Yes. Yeah, happy to help. So say it's a hobby. All right.
Okay. Thanks, everyone. See you next week.
Okay. Bye.
Thanks, everyone.
Bye.
Thanks. Bye.
Bye, everyone. Thank you and bye.